Okay, now the audio is running. So as long as I'm not using the laptop, I'm not ever present on this streaming. Guess that's life, I guess. But I don't know. Life in this mixed mode doesn't make sense to me. I'm either here, that's the other universe. You're either online or you're not online, or maybe you're in another universe. So this is mixed mode. I don't know. I'm here, I'm there. I don't know where I'm at. So now I take this line, go down, try my best to make that rectangle that is this, and this. I used 35 degrees to sweep it to here. So essentially I have a triangle that says, what's the distance from here to here? Because that's the distance that's here. So that is basically F1 in the Z direction. It's going down, so I have to make sure I've got that right. And it is 250, and it is not swept through the 35, it is swept through the 90 minus 35. Or you could say sine of 35. In other words, you know, I don't know if this makes sense. Okay, so here's your 30 degrees. Here's your hypotenuse. Here's your adjacent and your opposite. Now, if you look over here, that's got to be 60. So now, if you're looking reference to your 30 and your cosine of 30 is your A over your H, and then you're over here and you say the cosine of 60 from this perspective, that's O over. So that means that's actually sine of 60 should be A over H. So if you compare these two, you realize, well, one is just, what is the thing, 90 minus theta is equal to sine of theta or something like that? Or you could do that to the sine and you get back to cosine. Another way you could look at it is you shift your thing. If I take a cosine, it looks like this, right? If I take a sine, it looks like this. Okay, I'm trying my best. So if I shift it, this is 90 degrees. So I got to shift one of them 90 degrees. One, I could shift the cosine that way 90 degrees. Or I could shift the sine back this way 90 degrees and get the same plot. So in essence, you know, this all goes back to this thing where, okay, your dot product and then the other. That's the way I look at things now. He won't, I don't know what he will say in the book. He probably won't even address opposite, adjacent, or anything. He just writes it down because he's assuming that you've already gone through that concept. So I get now F1. Here, write it up here. Because I don't know I'm going to have a lot of space. Take that one. 250 cosine of 55? No, that's 35. Sorry. 35. That's the projected onto the plane. And then the sine of 25, and that's my I. And then I have my Y or my J going out here, and it's the 250 cosine of 35 as well, because it's that same vector that was projected in the plane. Then it was just projected back through 25 degrees. And then you got the one final thing, which is the minus 250, which I put a plus, but minus 250, and then sine of 35, and so you're done there. Okay, so the next one is, when I say the next one, I mean force 2. Force 2 is nothing more than, what is it, 450? No, 400 times cosine of the angle between the vector itself and the x. He swept at 120 degrees here. Now notice what's going to happen here. If I take the cosine of 120, it's going to be a minus number. And why? Because it swept past the thing and over behind the YZ plane, indicating that the component of this vector is going in that direction, which is opposite of the positive direction. And we'll find that in a second. And then the cosine between, hey, that's supposed to be a J. Sorry about that. The cosine between the vector itself and the vector which goes, the J vector which goes along this way, so that's the 45. And then the final one being the C plus cosine 60 there. Now, again, these are special numbers, this and this and this. You'll see combinations that won't have, most of the time if you get like something besides this, you'll get decimal spots. But it turns out the integers will end up with a 45, a 30, and a 30 somehow. So 90 and 120, 120 minus 90 gets you 30 going back that way, and you get 60 going up this way. So there's these few combinations that net you an integer for these three angles. He uses them a lot. There's a lot of things in the book that come out as integers that he forces to come out as integers. He makes life seem pretty, but life is messy. And so there's a lot of digits on stuff usually. So don't fall into that trap, you know, that you think everything should come out as an integer, because it doesn't. So then resultant would be the addition of this and the term before, not before it, but the term under it. So it'd be 250 cosine of 35 sine of 25 plus 400 cosine of 120 I. And then the second term is going to be this one, which is 250 cosine 35 cosine 25, which is that, plus 400 cosine 45. And then the final one is the minus 250 sine 35 plus 400 cosine of 60. And that's K. Now, before I do this, let me try to do, I'm going to go back to this Matlab and try again. I've done this before where I've made it, that's the wrong thing. I have made it so that well, I don't know. As a matter of fact, maybe I haven't done that. So what I'm going to do, first I'm going to fill out the vectors. So I'm going to do a clear, okay, and I'm going to do a clear the screen, and I'm going to set up and do my vectors. So I'm going to say F1 equal to, and I'm going to just copy that down, 2 as best I can, 250 times cosine degree 35 times sine degree 25. Now, how do I do this? How do I break it apart? One of the things you can do is make a vector in Matlab. Here's what I mean. So this will be the x component. I can do either a comma, a space, or a semicolon. I'll show you the difference between these in a second. And you'll see why this Matlab or Octave might be your friend. Have y'all, you did? Okay, so when you say you were familiar with Matlab, where did you get it? In 300, whatever that? Oh, yeah, okay. Did y'all get it there? Did y'all also get introduced to Octave? Okay. So if you have your laptop and you say, I don't want to pay for Matlab, octave.org. Did I spell that right? No, I did not. I said it right in my verbiage, but it didn't come out right. Turns out the syntax is exactly the same. So if you take most most Matlab codes and you turn around and type them into Octave, you'll get exactly the same thing. So if you're on your laptop and you're just like, I really want to use this, and I'll show you why you want to use this a lot through this section, just go download that on your, and there are places, let's see, you can do, there's an online place. Okay, there's several of them out there. I don't know if that's what that is. It's 84, 81, or whatever that is up there. But did you know you can use Octave online class? What's a script? Octave command prompt is down here. So I have this thing blocking my own view. So you can do it online, which means you can bring out your cell phone and do it. Me, on my regular computer, I just download Octave and use it there. It turns out if you look at it, the interface looks a lot like this. As a matter of fact, it even has the browser for the variables, the editor, the file thing. It's kind of set up to look like it. But for right now, I'm just going to use this. If I convert to back to my Surface tablet, and if I can figure that out one day, I'll go ahead and use the Octave. But for right now, I'm using this. So I'm going to enter this, and then I'm going to basically drop the screen and show you why you might want to use this a little bit. Okay, so cosine of 35, and then times, okay, sorry for the delay, cosine of, what does that say, 25? Cosine degree of 25. Did I put the D in there? Yeah, I did. And then, wait, did I do that? 35 and 25, and then a semicolon. I'm doing the semicolon right now. Minus 250 times sine degree of 25. Or was it 35? I think it's 35. Okay, then I close the brackets. Now, so I get this, and there's my vector, and so what it is, and I'll drag this down after I complete this one, but you'll see the X, the Y, and the Z component. So they're listed all three right here. Let me enter F2, and then I'll drop the screen, because I need the screen in order to see it all. So if you'll bear with me for a minute. So F2 is equal to, and I'm going to show you some weird things here. F2 is equal to, I have to make them the same. So if I made that a vector vertical, I need to make the next one vertical. I need to stick with what I mean. Okay, let me tell you what I mean. So I entered it with a semicolon. If I enter it with space, what do I get? Anybody remember? You get it listed that way. If you enter it with a comma, what do you get? You get it listed that way. If you enter it with the semicolon, which I'm going to do that because, then I can see them. I mean, some people are okay seeing them vertically. Some people are okay seeing them across. It turns out for our purposes, it really doesn't matter. As long as I'm consistent and throughout the whole problem, I decide to list it that way. In other words, if I'm going to use semicolons, I need to use semicolons throughout. So let me do F2. F2 is equal to 400, and I'll put a times, and I'll put the vector here. Cosine degree of, oh geez. See, that's the problem of doing it this way. Glasses, no glasses. Gosh, it says 120. And then semicolon, cosine degree of 45. Semicolon, cosine degree of 60. And then I get my vector. Now let me drop this. Let me show you why and what you can do here. So I've listed my F1 vector. I've listed my F2. So I got two vectors. You don't add them together, that's easy. So let's just add them together. So F resultant F2. Now, you may say, oh gosh, I knew that. I knew that was going to be. Now let's do something weird. Let's take the force vector resultant, which is just that number, that number, that number, and let's dot it with just a random vector. So let's just say I want to, this is very obtuse having to do this. So let's say I want to do it like this. I have some vector now that goes like here. Let's say I want to dot it with the unit vector in the F1 direction. Why do I want to do that? It really doesn't matter, because actually he just might ask you that question. So sometimes you don't really, it's not a matter of, at this point, it's not a matter of asking, oh, why would I do that? Maybe I want to find the component in that direction. So here, this one's easy enough. Let's find the unit vector of F2 and the unit vector of F1. So what would we do? Believe it or not, it's pretty simple. There's a thing called a norm. Norm of the vector F1, what do you think it's going to be? First, what did I type? Yeah, I typed a little f. So he's correcting me. He's saying, don't you want to do that for the capital one? So it's a good thing. So it's 250. Doesn't that make sense? Because if you look back at the problem here, maybe I'll do this. Okay, wait, there it is. But it's actually right here. Why is it? Because F1's length was 250. What do you think the norm of F2 is going to be? So there's this thing that, what is that? Square root of the sum of the squares. So if you go in here, I'm going to take the norm of F2, you get 400. So how do you find the unit vector? Unit vector in the first direction, I'll just call it U1. I like to, it's just F1 divided by the norm of F1. And I got to cross. So there it is. But guess what? If I want to take the norm of this vector, what do you think it's going to be? It's just 1. But I got two vectors now. Well, let's do the U2 one. So now I've got two unit vectors. Okay, look at this one, and think about this one for a second. It's minus a half. Actually, the number there ends up being 1 over square root of 2, and then the 1/2. Now let's see. And it makes sense, minus, and there's 30 degrees here, so it's whatever this is, 200 of it's going that way. And then you got that component, which is 60 degrees, and then you get the 45. So you can see it's giving you, if you look back, cosine of this gives you that first component. Cosine of that, 1 over square root of 2, and then a cosine of that. And that's what's showing up in that. Now, if I want to dot those two, if I want to dot those two together, guess what I do? Here's what I mean. I want to find the angle between F1 and F2. So there's a funny term here. Oop, I got to be in the right thing. It's called dot. Dot U1 and U2. There's a number right there. Now, if I take two unit vectors and dot them, basically that's the length of one vector, the length of the other vector, times the cosine of the angle between them, right? Remember that? So those both are 1s. So what do? I take the dot product and I take the inverse cosine of it, right? And that gives me the angle. So just like that, you're able to do arc cosine degree of those two. That tells you it's 86 degrees between those two vectors. And so the advantage of getting this Octave downloaded, does everybody have a laptop? Oh, you just downloaded it? Did it run? And, okay. So it looks just like it. You just type whatever you would type in Matlab, but you don't pay any money. There's also another one, but it's not as good. But Octave has been around a long time. It's every bit as good as Matlab. Now, if you get to extremely advanced things where you're working for a company, they're going to want you to buy Matlab because then you get a service contract and you have somebody to call and you can get things done. There's nobody to call for Octave. That doesn't mean it's a good program, but so if you keep trying to get your code for the book, if you have troubles, let me know. Okay, what's the?
If you announced office hours or put it online, I missed it, and I apologize.
Oh no, I did.
Okay.
I'm at 224 now, I think. Quarterly 224. I think I missed. Okay.
When are your hours? Because I want to discuss the homework with you.
Oh, okay. Well, actually, the best thing to do, can you come to class early?
Yeah.
Okay, because I have a class in here that goes from. Well, let me think about this. Here at 9, I'm done at 10. Then I got an hour. Then we start at 11, right?
Right.
So if you came a little early to here, then because I was trying to do that where I would go from here all the way back over there, but then I end up coming back here.
Yeah.
So I can just bring my Pop-Tart and tea and just do it here.
Well, it's up to you. The problem I'm running on the homework, number 16, I got the resultant force correct, but I can't get the angle to save my butt.
Oh, really?
I have it saying request answer because every way I tried it, I came up with a minus 84 degrees.
Oh.
And the answer on the problem, which makes sense looking at the picture, is plus 11 degrees.
Oh.
I have beaten myself senseless over the weekend trying to figure this out.
Okay, that's the wrong button to hit. Okay, wait. Okay, assignments.
Yep. That's the last one on the assignment, number 16. When does the quiz due, by the way?
Oh, it's a way far away.
Okay.
So it's like the Friday after the 11th, whatever that is.
I just saw a quiz on there. I was like, oh crap.
No, that's okay. So wait a minute. Oh, am I in the right thing?
Yeah, I'm ahead.
Okay.
Because you just released.
Wait, are
the
you in
assignment.
this one or in that one?
Number 16, that one. Problem 2.
Oh, okay. I was looking for 6. Okay.
Yeah, number 16 on the homework
Okay.
assignment. Yeah, that's it. Now I got the.
Oh, so you got the.
Yeah, they wanted the force A to B, given that the force A to C is 390 or something like that.
Oh, okay. Let me see. 390, 500. I don't see the 3. Oh, well, maybe they don't. Oh, okay. I'm looking at a different view. Okay. So in that one, let's see. So you got a force that's going to be pulling that way, force going to be pushing that way.
Yep.
And so, I don't know. It's just one of those things where, which way are you doing it? You're not doing it with vectors, are you? Or are you doing it with components?
I was doing it with components because that's the only way I could figure out to do it.
Yeah, it's easier to do because then you don't have to worry so much.
But the problem is my components came out with the right answer. I think it was number 16. Look at number 15 real quick. Maybe I was
Okay.
wrong.
Would this go back to the 15? Okay.
Okay. No, it was that one. It was 16.
Okay.
That one I got both of them wrong. Then I went and did some research and figured out how they did it, so I got the answer right. I just haven't retaken the homework yet. But that one, I have tried everything and looked. I found examples in the text like this and tried to follow the logic. But like I say, everything I did gave me an angle of minus 84 degrees, which I know is not theta.
Well, you know what? You know what I can do? I can go ahead and do this one on today's Monday, so that would be Wednesday. Okay. I can sort of poke around at that, because that one would fit in. Okay, so this is section. This is 225. Yeah, that should fit. We've already. Yeah, that would work.
Yeah, I think we covered that.
Yeah.
It's just that one's throws a curve at you.
Yeah.
But What I can't figure out is how I can get the force correct and not get the angle correct.
Yeah, that is weird. The only thing I can think of is maybe somehow well, we'll just do it on Wednesday. How about that?
Thank you, sir.
I had a quick question.
Yeah.
It was to do with, the last, fraction example that you used.
Uh-huh.
Because I understood this part, but this part right here, how you projected it for the.
Oh, okay.
250.
Yeah, so on this one, let's see if I can get rid of this window. Where did it go? Is it right? Oh, wait. There it is. So what I was doing there, so the 250, okay, so first of all, he drew his vector too far. I didn't like that, so I shortened it. So this length from here to here, or actually from the back to here, is 250 times cosine of 35.
And it's cosine because it's projecting.
Right.
Makes sense.
So in essence, it's a light showing up, hitting the end of the arrow, which I'm imagining the end arrow is there, not here. And it projects it on this plane right here,
Right.
and I see that. Then I have to project it through 25. So to me, I see 250, cosine 35, then cosine 25 gets me the y component.
And you multiply cosine 35 and 25 together?
Yeah.
Okay.
Yeah, because what you do is you take 235, that gives you this one.
Right.
Then you're taking the sunlight of that one and you're projecting it back over to here.
Right.
But then, this is where I say the other one. So I'll say, okay, well, if the light's projecting it back here, the other one over to here, from here to here, would be the sine. But it's based off of that 250 times cosine 35. And so then I'm back over here.
And so that would all be for I hat, because it's for the X.
Yeah, exactly. That's for the X and this for the Y. Then the Z, that's the situation where, you're down here and you're drawing the, I guess I had it on the board. I don't know.
I didn't get to several.
Oh, okay. Well, and that's kind of what I'm trying to do with these, this online stuff. And so what I did is I made a little square box, and then that's 90 minus 35, or the other one, which is the 250 sine of 35. So that's the way I always think. It's either dot product or it's the other one, which is a sine. And so, and that's why you see it by itself. It's just sitting there by itself. And so you start looking at it that way, that's why he introduces dot products later. And I kind of think they should be already, and we should be using them. But, and over the years, I've found that I just think that way, and I don't think opposite hypotenuse anymore.
Right. That's
So,
what I was getting confused myself with doing this.
yeah. So if you just think about you're sweeping a vector back somewhere, then whatever angle you sweep it with, and guess what? You're taking that vector and you're sweeping it back to here, you're sweeping it to there, and you're sweeping it to here. And so then you're like, oh, cosine 120, cosine 45, cosine 60. And so pretty soon you're comfortable with that dot equal cosine, and then it's like everything falls into place. So
I'm trying to get everything out. The 250, and then that's for the Y,
yeah.
for this projection. It's this 45.
Okay, yeah, now that 45 is only associated with the F2, and it's supposed to be the direct angle between the Y and the F.
Oh, that's the arrows.
Yeah, yeah, and so what we have is two problems. We have F2, which is done in that double projection, and then this one that just has the three angles.
Right.
So it's just, okay, what's the angle between this vector and the X, or the I? It's 120. Between the J and this vector, it's the 45. And then the vector itself in the K, which is this one, is 60. And so once you have those three, you're like, oh, okay, this one's easy. I just write it down. Fortunately or unfortunately, people generally don't go out and measure these. They generally go out and measure a shadow in a length, and they figure out the angle, and they do things like that. So as it turns out, we'll be progressing more towards that mindset in a while. But this is good to do to get you practiced and then get you there. And then later we'll figure out a very weird way, and that is, you know, a rope goes from here to there, and the length of that rope is whatever, but you're pulling down the rope, and then you got to figure, you know, your coordinates. Well, it might be this far, it might be this far. I mean, so this thing, so now you'll be looking at, you know, and if you follow his, this is the X, this is the Y, and this would be the Z. And so somebody would give you the coordinates of the end of that rope, and you would measure those, because you're going to find a ruler easier than you would a protractor. Nobody uses those anymore. Right. So you might find that it's at 10, 20, and 10. And somebody's pulling it. Well, you just figure out that vector, and then you take the unit normal, and you multiply times how many ever pounds. Say it's 1,000 pounds. And then it's like, oh yeah, now it makes sense. But then you can come back and say, well, what's the angle in any of those? So we'll be doing it backwards soon.
Attempting it from a geometry mindset.
Yeah.
A practical. The geometry is always there. You're just not having to acknowledge it.
Yeah. Yeah, and you get it, after a little bit, you get adjusted to it. So we go through these angles, and then we're off. The reason we do that too is we may have to come back to those. You know, what's the angle between this rope and that one? So you might see it like, say you have a trash can, and somebody's apparently pulling on the trash can, but you have 3 chains that are pulling it. And then you'll find out, well, I have a force along this component, force along that one, force along that one. They have to add up to be the equivalent of that. And so then you might be, well, what are those angles, you know? And so when you start, you may have to back out the angles later, whereas now we're starting with the angles. And so, you know, it's just statics. It's just, after you do some problems, you're like, oh, okay, I get it. And then you just go on, you know. Okay. I don't know that did I? I don't think I ever did. No, I didn't. Oh, well.